Welcome CEE424 students. We are Group 24. I'm Yunpeng Wang. My teammate Xinrui Zhang helped me design the slides. Today we're going to introduce you something about the fundamental and enhanced refreshment management. Since we have two topics to talk about, the fundamental requirements and enhanced requirements of refrigerant management. So we divided our presentation into two parts, and each part will follow the logic on the right side, the intent, why, the requirement, what, and the guidance, how to do it, and the tips, more about the details. First, let's focus on the fundamental requirements of the first part, intent. The intent of the fundamental refrigerant management is to reduce the stratospheric ozone depletion. First, we need to know what is CFC. CFC is the chlorofluorocarbons, which contributes to the depletion of the ozone layer, causing harm to both human and ecosystem. So we need to try our best to eliminate or reduce the usage of it in our equipment. And we need to know more about the requirements, how exactly we should do to obtain this credit. The basic requirement involves prohibiting the use of CFC refrigerant in new HVAC and R system, and phasing out CFC should situation call for the reuse of the old systems. However, it is also worth noting that a small equipment such as standard refrigerator or water cooler, they are exempt from the requirement. We will move on to steps to achieve basic refrigerant management. First, we need to know the guidance for the new equipment. The approach for the installation of new equipment to earn this credit is pretty straightforward. We should try our best to avoid the use of CFC in the new equipment. To do that, we need to know that this is a responsibility for the mechanical engineers. They should provide a specification for our new equipment and pay close attention to the systems that are be selected. As elder and retrofit system with high efficiency rating tend to use CFC as refrigerant, which we should pay more attention to that. And for major renovation project, the project team needs to inventory all the HVAC and R system that utilize CFC, and then either phase out the use of CFC or reduce the leakage of the refrigerant. There is also a scenario that the use of CFC cannot be phased out before the conclusion of the project, and we should do the following steps to include this scenario. First, develop a phase-out plan with schedule. And second, develop a narrative describing why CFC phase-out can't be achieved before the conclusion of the project. Once we've done that, we also have an opportunity to earn this credit in the major renovation part. The last chapter of the fundamental part is the tips. In this part, we will include some for your information detail we need to know to get the credit. At first, I really hope you guys can read more about the details part in the page 395, because we can only include several details that we think are important in the slides. It's impossible for me to mention all of the aspects. So when we talk about minimizing the refrigerant leaks, we all know that it's very important, because only the refrigerant leaks that can be harmful to the environment, to the ozone layer. And the requirements of reducing the leakage of it are summarized in the slide. In general, the requirement stipulates the recycling and recovering of the refrigerant, maintaining recycle and recovery equipment in compliance with regulations, conducting repairs on large volume leakage, implementing the safe disposal of refrigerant, and prohibiting the personnel from knowingly violate the above rules. Then we enter the second part of our presentation, the enhanced management of refrigerant. Still, we will talk about intent first. The intent of the enhanced refrigerant management is to reduce ozone depletion and support only compliance with Montreal Protocol while minimizing direct contributions to climate change. The idea of refrigerant being detrimental to ozone layer and the climate may sound like cliché, but it nevertheless holds the truth. Despite the fact that newer version of CFC-based refrigerant utilizes fluoride instead of chloride, making it less toxic to the biomass, it still maintains the capability to contribute to the global warming, to introduce chain reactions, and to turn the ozone into the normal oxygen. Thus, the intent behind this credit is to minimize the harmful effect of the refrigerant towards the ozone layer and the climate as a whole. And this credit can apply to the following projects. And second, we will know more about the exact requirements of this part. For all projects other than retail, we will talk about retail later. The project team faces two options to achieve this credit. The option one is to use low-impact refrigerant meeting credit criteria or no refrigerant at all. The other is to take controlled risk and calculate the impact of the refrigerant employed. And there are some detailed description in the slide. I hope you guys can read it. Here are more explanations on the option 2 on how to calculate the impact of the refrigerant. To calculate the impact on the environment and verify if such level of impact meets the criteria, we calculate the life cycle ozone depletion potential, which is LCODP, and LCGWP, which refers to the life cycle direct global warming potential. These two are two very important indexes to compare if the impact meets such criteria. Here are some formulas for IP units and SI units to how to calculate the impact of their refrigerant on the environment. The adding of LCGWP and LCODP to the power of 5 to see if the result is maintained under a certain threshold. Depend on the site of unit used. LCODP and LCGWP are calculated by summing the lifetime refrigerant leak or the lifetime refrigerant loss, multiplied by the refrigerant charging rate divided by the equipment life, and then multiplied by the ozone depletion potential or global warming potential of the refrigerant. And one more thing to mention, when calculating the impact of the multiple type of equipment, use the weighted average method. And then we will have a step-to-step guidance on how to do the enhanced refrigerant management. To achieve this point, we should do several steps to follow it. The first one is to document the refrigerant use of HVAC system. We should know that this will exclude small system of less than 0.5 pounds. And if the project fell to the requirements for option 1, go to option 2. Here is the definition of option 1 and option 2 for your information, in case you forgot what is it. And if the option 1 ended up chosen, we should calculate the environment impact and or refrigerant with potential indexes drawn from table 1. And we will show you the table 1 and 2. Table 1 and 2 will show in the page 455, and it's used in option 1 and option 2 to calculate the refrigerant impact. Here is the last part of our presentation, the tips of the enhanced refrigerant management. For the retail project, they will face more stringent policies. This type of project will need not only fulfill the requirements for option 1 and 2 for all their HVAC system, but also comply with additional standard for commercial refrigeration system. The standard includes complete exclusion of ozone-depleting refrigerant and a maximum level of refrigerant charge and leak. As earlier stated, the leakage of the refrigerant can be hugely detrimental towards the environment we live in. Not only does it deplete the ozone layer, but it also contributed to global warming way more potently than carbon dioxide, as it shows 17-18 times. However, just as stated in the prerequisite, equipment utilizing CFC or HCFC based on refrigerant are generally effective. Project team may face a trade-off between eco-friendly refrigerant and reduced energy and operation cost. Thanks. That's all for our part. We are Group 24. Thank you.